Well, welcome all to our final spring 2013 colloquium presentation. Today is Tuesday, April 30. My name is Dr. Anthony Bernier, and I am pinch hitting today for our regular colloquium host, Dr. Bill Fisher. And I'm going to be introducing our guest speaker today, Dr. Tefko Saracevic. And we will have a presentation by Dr. Saracevic, and then at the end of the presentation, we will open the mics up for question and answers. If you would like to post comments or questions in the chat room in the lower left-hand corner of the Blackboard Collaborate screen, please feel free to do that throughout the presentation, and we will go back and scroll through that at the end of the presentation, and or we will take live mic questions at the end as well. So I would like to formally, it is my pleasure and delight today to welcome Dr. Tefko Saracevic to our spring presentation. Dr. Saracevic is Professor Emeritus at the School of Communication and Information at Rutgers University, where he served as Associate Dean between 2003 and 2006. His published scholarship ranges widely on a variety of LIS topics, and they include testing and evaluation of information retrieval systems and digital libraries, notions of relevance in information science, human aspects in human-computer interaction in information retrieval, user and use studies in information science and librarianship, user-derived value of information and library services, search engine web queries, and various other aspects of digital libraries and information services. Dr. Saracevic has taught, lectured, consulted, and presented papers at meetings in 48 different countries, including serving as keynote speaker at over a dozen international conferences. He has served as president of the American Society for Information Science, and he received the Society's highest award of merit, among other top awards. Tefko's publications are also very well regarded. He ranked first in citations to his work among thousands of authors in articles published in the Journal of American Society for Information Science and Technology. Between 1985 and 2008, he served as editor-in-chief of the International Information Processing and Management. And he remains active in his emeritus status, teaching online courses, writing, participating, and even organizing international conferences. So today it gives me great pleasure on behalf of this faculty to welcome Dr. Tefko Saracevic.
Thank you very much, Anthony. I appreciate the introduction, and I also appreciate the invitation. At the moment, I have, as you can all see, my Rutgers hat on. Let me take it off, and soon we will start with the presentation itself. So the topic is relevance in information science. You have, under my name, you have my email if you want to contact me. And then you have the URL for the place where you can find the articles. Actually, don't copy that URL. Just go to Google and put my first name in, Tefko, T-E-F-K-O, and the first thing that comes up is my own site, and then just go to articles. Anyhow, what we have is that a fundamental concept, that relevance is a fundamental concept or a fundamental notion in information science. Now, every scholarly field, every discipline has a fundamental or basic notion or concept or idea, or a few. Think of physics. The basic notion there is the energy and matter, jurisprudence, justice, biology, life, and so on. And these are the hardest to deal with. Here, I pilfered from someplace a picture where it shows that eyeglasses are certainly relevant to wearing it relevant to the sun. We have two large questions that we are going to address in this presentation. The first question is why? And that question is, why did relevance become a central notion of information science? The second question is what? And there has been considerable amount of research done on relevance. So what did we learn about relevance through research and information science? By the way, if you download my slide, then the URLs for all the things that I have in the slides and the references are in the notes, so you can access them after the downloads. What we are going to have after these two large questions, which is part 1 and part 2, it's 4 introductory slides basically dealing with definitions. I took this from online Merriam-Webster and the definition of relevance, and the Merriam-Webster defines relevance as a relation to the matter at hand. The emphasis, I added the emphasis of matter at hand because in the next slide we'll be talking about it. It also defines as practical and especially social applicability. For instance, it gives an example of pertinence, giving relevance to college courses. And we all who are professors are trying to give relevance to our college courses. The second definition is dear to our hearts in our field, is the ability. Relevance is the ability as of an information retrieval system to retrieve material that satisfies the needs of the users. So what do we mean by matter at hand? It's basically, it's a context in relation to which the question is asked. It's a context in relation to an information need is expressed as a query. It's a context in relation to a problem is addressed. So there is no such thing. There is no such thing at all as relevance without a context. I'm using one axiom which says one cannot not have a context in information interaction. I took that from an article, several articles from Paul Watzlawick, who did a number of articles about axioms communication, and his first axiom is one cannot not communicate. And one of the critics said that this is lousy grammar but impeccable logic, and one cannot not have a context in information interaction is lousy grammar and impeccable logic. So relevance is always contextual, and that kind of defines why it's important to deal with relevance. Let me go to another issue, and this is the issue of a number of terms that are being used as synonyms or near synonyms for relevance. So by any other name, relevance remains relevant. So we have many names that connote relevance, such as pertinent, useful, applicable, significant, germane, and so on. Nowadays, even truthful. The connotations for each of these may differ, but the concept is still relevance. And here is what good old Shakespeare said in Romeo and Juliet: "A rose by any other name would smell as sweet. Relevance by any other name will be irrelevance." And this is the last slide before we go to the questions. And I would like to point out that in information science, in general, there are two words. There's one word, which we will call a system word. It's where the information retrieval systems offer an answer their version of what may be relevant. And they use ever-improving algorithms to do that. But on the other hand, you, me, people, humans, go their way and assess relevance of what is provided in relation to their problems at hand, in relation to their own context and criteria. These two worlds, the system world and the human world, interact. Of course they interact all the time. Particularly, you think of any questions with search engines, they interact and how. But what I'm covering in this article, in this presentation, is the people, the human world of relevance. I'm not covering how information retrieval deals with relevance, and there are thousands upon thousands of articles with that particular issue. So let's go to the first question. Why relevance? Why did relevance emerge as a central notion in information science? We'll start with a bit of history. Vannevar Bush wrote an article in September issue of Atlantic Monthly in 1945. And the article title is As We May Think. And if you download this presentation, click on Vannevar Bush, we will get a description of him. And if you click As We May Think, you will get the article itself. Well, it became a very, very influential article that is being cited to this particular day. Why? Well, one has to consider who Vannevar Bush was. He was a professor at MIT, an inventor, but most importantly, he was the head of the United States scientific effort during the Second World War, the scientific effort that produced the atomic bomb, that perfected radar, that did wonders with lasers, and so on. So when a person like Vannevar Bush, who had a lot to do with the successes of the U.S. science, when he writes, people listen. So he did two things. As a good engineer, he defined the problem as the massive task of making more accessible of a bewildering store of knowledge. And the problem of that massive task of more accessible of a bewildering store of knowledge is still with us, and it's growing. But he did the second thing. He suggested a solution, a technological fix to the problems. He suggested an imaginary machine called MEMX. He called it MEMX, which will deal with association of ideas, will duplicate mental processes artificially. Remember, this was written in 1945. And he has already ideas about artificial intelligence, and a few years later, Calvin Morris, a physicist and mathematician, also from MIT, has, in an article called Zeta Coding, has coined the term information retrieval. And he defined what information retrieval is also. He said that information retrieval embraces the intellectual aspects of the description of information and its specification for search, and also whatever systems, techniques, or machines that are employed to carry out the operation, to provide information useful to users. It's interesting, before Calvin, the information retrieval as a term did not exist. So he coined it and he defined it. Also, it's interesting that Calvin Morris was a son-in-law of Watson Davis, and Watson Davis was the founder in 1937 of the American Documentation Institute, who today is Association for Information Science and Technology. Okay, I'm advancing again. So what we have in information retrieval, that the emphasis was not only on organization of information as it was for centuries in libraries, but it was even more on searching. Why was that? In information retrieval, the emphasis was not only on organization of information, as it was done always in librarianship, for instance, in many other disciplines, but even more on searching. And why? Because the technology of the day, when it was developed, and later on especially computers, was extremely suitable for searching. In the beginning of information retrieval, information organization was done by people, and searching was done by machine. Nowadays, we have information organization mostly done by machines. Google does all of it by machines. Yahoo does some of it by machines, some of them by people, humans as well. And then searching is not almost exclusively, it's exclusively by machines. I'm changing to slide 12. In this relation, I would like to mention two important pioneers that have been instrumental in doing a lot of things in the application of technology, particularly computers. One is Hans-Peter Lund, a Viennese who immigrated to the United States around just before the Second World War, worked his life at IBM, had many patents at IBM. And he is the first who described searching in a way to using Venn diagrams. He wrote many other articles that have been significant. He was the first one to apply automatic indexing and even automatic creation of abstracts. So he was an inventor, a scientist that has seen the potential of technology, and what searching was, what important for Hans-Peter Lund was not only creating of information representations, but also for searching. He died in 1964 while he was the president of the then American Documentation Institute, now Association for Information Science and Technology. Mortimer Taube also died very young, at 55. He was an entrepreneur. He started a company which he called Documentation Inc., and he pioneered coordinate indexing that coordinates the searching, and he was the first to describe Boolean algebra. So what we have is that many of the information retrieval techniques have been developed on one hand by a large and humongous company that put a lot of money in information retrieval, such as IBM, and then by a smaller company such as Documentation Inc. That pioneered new ways of doing things and were out really to make money, and why not? I advance to slide number 13. So searching became a key component of information retrieval. So we have, as started with Lund and with Taube, we have extensive theoretical and practical concern with searching, and technology of the day, and then later computers in particularly, were uniquely suitable for searching. Before computers, there have been a number of technologies that have been used, such as edge-notch punch cards, peekaboo systems, uniterm cards, and so on. So what is searching all about? Searching is about retrieval of relevant answers. Thus, because of concern with searching, relevance emerged as a key notion. I am on slide 14 now. The aboutness, to make a comparison, somebody changed the slide, okay, is a key notion for bibliographic classification, for subject headings, for indexing languages. And aboutness has been used in organizing information records for centuries. So what we have is that a choice of a given classification code in Dewey's code or Library of Congress code, a choice of subject heading of an index term denotes what the document or part is all about. The searching in organization of information is assumed but not addressed. It's really given and taken for granted. And let me explain this a little bit, taken for granted, with a little bit of history. Charles Amy Cutler was a leading American librarian in the 19th century, died in 1903, but in 1876, he published a very famous book, Rules for Dictionary Catalog, and another edition was issued a year after he died in 1904. And what he did there is, among others, defined objects. And by objects, he meant objectives of a catalog. And here is a quote: to enable a person to find what the library has, a given item, to show what the library has, to assist in choices. 120 years later, IFLA, International Federation of Library Associations and Institutions, have defined FRBR. Another edition came out in 2009, and FRBR, I always break my tongue when saying it, stands for Functional Requirements for Bibliographic Records. And they defined it 4 generic user tasks in relation to the elementary uses that are made of the data by the users. And the 4 tasks are find, identify, select, and obtain. So 120 years later, they basically said the same thing that Charles Amy Cutter said in 1876. So what we have here is a concern with aboutness, which is a fundamental notion that is related to organization of information. And that fundamental notion relates to a subject. In a broader sense, it relates to epistemology. While relevance is a fundamental notion that is related to searching for information, and it relates to problem at hand and context, and in a broader sense to pragmatism. So relevance emerged as a central notion in information science because of practical and theoretical concerns with searching. So let's now go to the second part, and I'm advancing to slide 17, and in the meantime, I'm drinking some iced tea. And if the audience has something to sip, please go ahead. Well, what happened already in the 1950s, that when a number of information retrieval systems have developed, it happened the same thing like that happens with any system development, and that is basically that from the outset, the people who develop the system claim my system is better than your system. Well, which one is better? And the answer is, let's test it. Let's not forget the people who develop information retrieval systems have been, by and large, scientists and engineers, and it was the second nature to them to test it. But they have 2 questions. What criterion should we use for testing? And then what measures should we use based on the criterion? For instance, time is criterion, hour, second is a measure. By the end of the 1950s, things got settled on those 2 questions, criteria and measures, and they are the same 50, 60 years later, now that we are in 2013. So I'm advancing to the next one, which is slide 19. What happened is that relevance got closely connected with information retrieval testing. In 1955, Alan Kent and James W. Perry were the first to propose 2 measures to test of information retrieval system. At that time, most of them, by the way, were chemists. And at that time, they were at Center for Documentation and Communication Research at Western Reserve University. And the measures that they proposed one was relevance, and because of the confusion, later on relevance was renamed precision, and the second one is recall. In the next slide, I'll define them. So what they proposed is a scientific and engineering approach to testing, and as I mentioned, this is not surprising because they were engineers. Here are definitions. So relevance is the criterion. But the definition of the measures is the precision is probability that what is retrieved is relevant. Conversely, how much junk. So if I say that my precision is 70%, that means that 70% of stuff I retrieved is relevant and 30% is junk. Recall is probability that what is relevant in a file is retrieved. I have a large file, let's say Medline or whatever it is, and I ask a question and I retrieve 3% or 30%, but I miss 70% of what's in the file. So my recall is 30%, and I missed 70% of relevant stuff. So there is a probability, both of these measures, a probability of agreement between what the system retrieved, or in terms of recall not retrieved, as relevant, which we call now systems relevance, and what the user assessed as relevance, we call user relevance, where user relevance is the gold standard for comparison. To this day, we're using these two measures and variations on the theme, and to this day, user relevance is a gold standard for comparison. Let us recall, I'm advancing to slide number 21. This is a bit funny but really confirms the law of unintended consequences, where relevance can really up as a problem. In mid-1950s, they have been competing information retrieval system. One of them were by Armed Services Technical Information Agency, and the other one was coordinate indexing, which used unit terms, which are basically keywords developed by Documentation Inc., and I mentioned Mortimer Taubey as a founder. So they were competing for money, and the question came, you know, is the subject better or the unit terms better? So they agreed to a test. So what they did is each group indexed 15,000 documents, and they had common questions, 98 question search. However, and this is extremely important, however, relevance was judged by each group separately. So the result, the first group had 2,000, found that of the stuff that they retrieved for 98 questions, 2,200 were relevant, and the second group found that 1,998 were relevant, but the agreement between the two was quite low. Then they had peace talks. They sat together, and even after these talks, the agreement came to about 30.9%. So the test, the first test of information retrieval collapsed, not because of the test itself, but because of disagreement on relevance judgments. So what the people who do testing of information retrieval use, it's this: never, ever use more than a single judge per query. And since that day to this day, information retrieval tests don't use any more than a single judge or replacement for a judge, whoever it may be, for the query. I'm going to slide 1922. The most famous tests in information retrieval have been done. Somebody has changed the slide to 14. Let's go to 22. Okay, more. Okay, here we are. Don't change it anymore. I was not changing that. Randy or somebody else was changing. Anyhow, Cranfield Test lasted for about 10 years, from 1957 to 67, and they are named Cranfield because they have been done at Cranfield Institute of Technology in England, and Cranfield Institute of Technology was famous because it has been instrumental in developing of Spitfire, which played a critical role in battle for Britain in the Second World War. Anyhow, it was funded by NSF, and that's another very interesting historical way how it came about. But I'm going to skip that history. What Cleverton and his group did, that they did control testing. They involved different indexing languages. However, they use the same documents and they use the same relevance judgment. Remember, one judge per query. They have used a non-interactive information retrieval model, which we call today the traditional model. And many results that Cleverden came up with were quite surprising. And people, for years, people refused to believe. One of the results was that simple keywords had, and I quote him, high ranks on many counts. And here we have subject headings and complicated classification schemes and so on. And now we have simple keywords. And that were as good as anything else. And remember that these simple keywords were critical to show that computer methods, simple keywords, that's what the computers did, were as good as anything else. So Cleverden and his group developed something that is called the Cranfield methodology for testing. Remember, that was done in between 57 and 67. And this is still used today in text retrieval conference, which is a large text conference every year, which started in 1992, and it went is going still strong to this day. I'm going to the next slide, slide 23. And here is something that is known as Cleverden law. Generally, there is a trade-off. If you look at the left side of the slide up there, precision, at 9, you can have high precision, but at the price, low recall. If you look at the right side, you can have high recall, but at the price, low precision. So recall can be increased by retrieving more, but at that time, precision decreases. And this is a graph that was done at one of the text retrieval conference tests. And precision can be increased by being more specific, but then recall decreases. Some users want high precision. For instance, students that have on Monday a paper due, on Sunday doing a search, they really want a high precision. Give me one or two that are relevant, forget the rest. And pattern searches, they really want high recall. They are they want to be sure not to miss anything else. I'm going to the next slide, and 24. The first experiments on relevance have been reported in 1960 and 61 by an IBM group, and it's not surprising that it was an IBM group. Remember that Hans-Peter Loon was there, and the first article ever that came out was the article entitled Reevaluation of Machine-Generated Abstracts. And it came out in the volume 2 of Human Factors, which now it's in its 50th or whatever volume, and it's world-leading journal in Human Factors. The second article, Comparison of 4 Types of Lexical Indicators of Content, came out in American Documentation. And the third article, Relative Effectiveness of Document Titles and Abstracts for Determining Relevance of Document, came out in Science magazine, and Science being one of the most important and the most cited magazine science journals in the world. This article brought a lot of attention to the issue of relevance. I estimate, going to extensive literature searches, that over the years there were about 300 or so experiments done with relevance. There have been very little funding for relevance by U.S. agencies. There were really only 2 large projects funded, and they were done in 1967, one at System Development Corporation and one at Western Reserve University. It's interesting that 3 of the 4 principal investigators in those 2 projects were psychologists, and they brought in psychological methods which are followed in many respects to this day into relevance research. A variety of throughout the years in those 300 experiments, and so a large variety of factors and variables have been addressed. Now, let's go back to and now I'm on slide 25. Altogether, we have 32 slides of text. Anyhow, Cranfield methodology, and I mentioned what it is, has the following assumptions about relevance. One of them is that relevance is static. That's what the traditional IR model is. And further, that relevance is topical. It means that relevance is only aboutness, no other factors enters in. Relevance is binary, either relevant or not relevant. Relevance is independent. That means if you judge relevant one article, 5 articles later, you judge independent. Relevance is stable. It doesn't change over time. Relevance is consistent. People are consistent in their judgment of relevance, and relevance is complete. So if you pull from various sources, nothing is left. These assumptions have inspired a number of relevance experiments on every one of them. And the main finding from all these experiments, none of these assumptions holds. But science always deals with simplified assumptions, and these simplified assumptions enabled the rich IR test and many improvements. Okay, we are now on slide 26, my slide 26. So let's address some of these questions. So on the first assumption was, do relevance inferences and criteria change over time? After a number of experiments, they certainly do. And here are generic results from all the experiments if we take for a given task. User inferences are very much dependent on the stage of the task. At the beginning of the task, when you, for instance, a scientist or a group of scientists do the proposal, what is relevant is very different than when they're in the middle and then when they're in the end. And by the way, that was a finding of one of the studies that I mentioned, the 2 studies that have been supported. So what we have is that different stages of a task, there are different selections of items to be relevant, but there are at different stages also we have very similar criteria, but we assign different weights to each of the criteria, thus different selections. The more we increase the focus we have of any task, we have increased discrimination and more stringent relevance judgments. So what it was shown that information retrieval in general and relevance in particular, relevance inferences in particular, are a highly dynamic process. I am now on slide 27. Remember, we had 6 assumptions, topical, and here are 3, and the next slides will have another 3. It is first assumption that relevance is topical. Yes, topicality is very important, but it doesn't play an exclusive role. We have cognitive factors, variables that play a role such as user background. We have situational variables such as task complexity. We have affective variables such as intent and motivation of the users. Relevance judgment binary, yes or no, relevant, not relevant? No. The relevant do not judge only binary, but they judge on the continuum and they compare. However, a few experiments have showed that relevance is actually bimodal. There is a bunch of relevance judgments that come on the one end, relevant, and another at the other end, not relevant, with smaller peaks in the middle range. Is the order is a relevant judgment independent? Documents. Well, the order in which documents are presented to users seem to have a considerable amount of effect. So it doesn't matter. It does matter if you present documents in one way or the other way, and that's something that Google is struggling for ever and ever, because they have found out, as many other studies, is that overwhelming majority of users don't go beyond the first page. So near the beginning, it seems that documents that are presented early have a much higher probability of being inferred as relevant. Let's go to the second three variables, and I'm now on slide 28. Are relevance stable over time? They're not completely stable. They change over time as task progresses and as people learn and learning advances. However, criteria for judging relevance are fairly stable. Time relevant judgment changes. Criteria stay. Okay, let's have some more iced tea. Consistent expertise. We have this finding that the higher expertise, we have a higher agreement and less differences. The lower the expertise, everything becomes relevant, more leniency. The most prominent feature in all the tests is individual differences. It is a most prominent factor in relevance inferences. Experts agree to up to 80% of what's relevant. Others agree around 30%. Remember, the first test they agreed something like 30.9%. Well, the more judges we have, the less agreement, and that's the first test, showed that clearly. If we do pooling of different search methods or different files, is it complete? No. With more pools or increased sampling, more relevant objects are found. So that's never ending. I'm going to slide 29. And here are a bunch of other experiments, and I selected in this and the next slide two types of experiments. One of the variables that is being addressed is what clues and on what basis and what criteria the users on what basis the users make for relevance judgments. Oh boy, did I quadruple this. Anyhow, so this brought along so-called clues research. So what are the criteria for content? Well, what's the topic, but also what's the quality, what's the depth, what's the scope, what's the currency, what's the treatment, what's the clarity. Now think how do you do relevant judgment when you write a paper? All of these criteria enter. And then the object, the document or picture or whatever it is, what's the characteristic of that object? For instance, plays a role, what's the type, how they are organized, what representations do they have, in what formats they are, how available they are, how accessible they are, and what costs they have. Validity, and this is a big deal today, what's the accuracy of information provided? Authority, trustworthiness of sources. Can we verify it? So these are criteria that users make in judging various clues. The next slide is my slide 30. On what basis and criteria do users make relevant judgments to match their context? So basically we have agreed that the experiment showed us 4 kinds of matches. We have a use or situational match, and the users asking the questions of the documents, what is appropriateness to my situation or my task, what's the usability, what's the urgency, what's the value in use. Then we have the cognitive mask, how does it fit to your noodle, and that's, how is the object, how do I understand it. Novelty for me, what mental effort do I have to use. Then we have affective match, and emotional responses to information. Is it fun? Is it frustrated? Is it uncertainty? that we have in those objects, and then we have belief match, which is personal credence that we give to information and confidence that we have. So we have a large number of criteria that has been investigated in these 300 plus experiments, and as to matching, as to clues, and as to assumptions that are made for information retrieval test. So I'm now on slide 31. What is one of the major, no, not one, it is the major general finding and conclusion from relevance experiments. And that is that relevance is measurable. We can study it. We can derive conclusions. We can see variables that affect it. We can, on the basis of that, we try to build information retrieval systems that are better answers and so on. I don't have a slide here, but I want to mention it's kind of interesting that all these results came from experiments that have been open. Now we have a situation where a tremendous number of relevance experiments are being done in situations that are closed. I've been to some presentation by officials from, or scientists from Google, and heard where they hinted, and from Microsoft, they hinted of what experiments they do. They don't publish them. They use them in order to improve their methods of retrieving relevant answers. So what we have is we have a whole number of experiments that are not published and are not public. Now, this is the same thing like in the pharmaceutical industry, they do the same thing. Okay, here we come to the last slide before a few pictures. In conclusion, and that is the end to our presentation, information technology and information systems will change dramatically. They will change even in the short run and in totally unforeseeable directions. We can't predict what is going to go on, even in the short run. However, relevance is here to stay, and relevance is here to stay for a long time, if not even forever. In the next few pictures, I will show you that relevance has many faces, not only scientific articles and objects that we have been discussed so far. Here is, and I am on the slide 28, a different technology that is used for transportation of relevant answers, and this is a mobile Camel library in Kenya. And here are a set of users that look at what is relevant to them eagerly from that mobile Camel library. And here is an unusual relevant service that libraries are increasingly using. For instance, the San Diego Public Library has therapy docs that help people with reading, and they're trained to do that. And here is a picture of the University of Michigan in Ann Arbor, where therapy dogs are helping students to use the library, and they have become very popular. And then we have a very different kind of a lending from library at public libraries. The San Francisco Library has a seed library, where you borrow seeds, you grow seeds, and then at the end of the fall you return back the seeds. And here are some examples of the seed library, and we're on slide 36, by the way. So now we are a slide where I say thank you. And this is a picture of Sandy Hirsch, who is the dean. She is the dean and good friend at the School of Library and Information Science in San Jose, and she is actually the one that first invited me to this colloquium. And thanks Sandra, thanks everybody. Hvala is a term in my own language, creation, and it means thank you. And if you put this whole presentation in Wordle, you'll get this kind of representation. So let us go to the first slide, which where you have both the address and the URL, and I'm open to questions.
Thank you very much, Topical, for a fascinating survey of relevance and its historical development. I want to especially point out how much my own appreciation is for a presenter who focuses his material on core questions and answers those questions as part of the presentation, rather than simply sharing a narrative with us. I would like to open the floor and for people who would like to ask a question.
My question relates to experimental settings. And if individual differences have such a profound impact on relevance judgments that agreement can be as low as 30%, I was wondering if that impacts the representativeness of findings when a single judge is used to assess relevance.
Well, you put your finger on the key controversy in information retrieval. In my opinion, it does. And there have been experiments, and I wrote an article once about it. So I now, over the years, when the first time it was the question was raised, since people are inconsistent and have individual differences, how does this affect the test results? And over the years, there have been only 8 tests, 8 experiments done. And basically what the experiments came up with is that, yes, there are differences, but the ranking of information retrieval systems will remain stable and the same, so it doesn't matter. It's inconclusive. I looked at these experiments with in great detail, and came up it's inconclusive. But it seems that they accept, the information retrieval community, particularly in computer science, it accepts the facts. Oh, it doesn't matter. So while it does matter, it's accepted that as if it doesn't matter.
Okay, thank you. It's good to know, I guess, where it stands.
Okay, thanks, Teresa. Good question.
We really do need to wrap up our hour-long colloquial presentation so that we are consistent with our other presentations, but I want to invite people to stay on after we close the recording and interact with Topical as long as we need to. There are a number of other points that have come up in chat that just seem to have flooded. So I'm not sure if those are technical questions or if those are content questions, but we'll deal with them as soon as we're offline. So Randy, if you wouldn't mind stopping us shortly. Dr. Saracevic, thank you very much for spending time with us today. And again, on behalf of the faculty, thank you so much for bringing your presentation on relevance in information science to us. Thank you again.
Thank you very much. Mm-hmm.